we're all used to the traditional operators like addition and subtraction and multiplication and division. And we've seen there's multiple ways to represent this. But what we're going to do in this video is a little fun. We're actually going to define our own operators. And what's neat about this is it kind of shows how broad mathematics can be. And on a more practical sense, it's actually something that you might see on some standardized test. And the reason why they do that is so that you can appreciate that these aren't the only operators out there, plus exponentiation and all those, that in mathematics you can define a whole new set of operators. So let's just do that. So let me just define x diamond y. And I'm going to define that as, I'm just going to define that as 5x minus y. So you could view this as kind of defining it a function, but we're defining it using an operator. So if I have x diamond y, by definition, we have defined this operator. That means that's going to be equal to 5x minus y. So given that definition, what would 7 diamond 11 be? Well, you just go to the definition. 7 diamond 11, for instead of an x, we have a 7. So it's going to be 5 times 7. So let me do it. 5 times 7 minus, and instead of a y, we have an 11. So one way to think about it is, in our definition, every place you saw an x, you can replace with a 7. Every place you saw a y, you replace with 11. So you have minus 11 over here. Let me make the number. So this is the 7. This 7 is this 7. And this 11 is this 11 right over here. And then we just evaluate that. So 5 times 7 is 35. So this is equal to 35 minus 11, which is equal to 24. So 7 star, or not, this isn't a star, 7 diamond 11 is equal to 24. We can define other things. We can define something crazy like, let me define a, well, I mentioned a star. Let me use a star. A star, let me write it this way, a star b. Let's say that that is the same thing as, I don't know, a over a plus b. And so same idea. What would 5 star 6 be? Well, you go back to the definition. By definition, every place where you see the a, you would now replace with the 5. Every time you saw the b, you would now replace with the 6. So this is going to be equal to 5 over 5 plus 6, a plus b. A is 5, b is 6, over 5 plus 6. So this would be 5 11ths. 5 11ths. And then you can compound them. And we haven't defined any order of operations for these particular operations that we've just defined. So we're going to be careful to use parentheses when we put some of these together. But you could do something interesting, like negative 1 diamond, negative 1 diamond, 0 star 5. And once again, we just focus on parentheses, because that's the only thing that's telling us what to start on first, because we haven't figured out, we haven't defined whether diamond takes precedence over star, or star takes precedence over diamond, the way that we have that saying that, hey, you do multiplication before you do addition. We haven't defined it for those operations, but that's what the parentheses helps us do. So we want to evaluate this parentheses first. 0 star 5, that is 0. So now you could view this 0 as the a and the 5 as the b. So it's going to be 0 over 0 plus 5. Over 0 plus 5, which is just going to be 0. So this over here is 0 over 5, where it just goes to 0. So this whole expression simplifies to negative 1 diamond, this diamond right over here, diamond 0. And now we go to the definition of the diamond operator. Well, that's 5 times the first number in our operator, the first term that we're giving the operator. I guess you could think of it that way. So 5 times that. So it'll be 5 times negative 1. X is negative 1 minus y. Well, y here is the 0. Minus 0. So 5 times negative 1. 5 times negative 1 is negative 5. And you will see, and the idea here is just to make you feel comfortable defining new operators like this and not being daunted if all of a sudden you see a diamond and they're defining the diamond for you and you're like, wait, I never saw a diamond. And the reason they're actually defining it for you. So you shouldn't say, I never saw a diamond. You'll say, oh, well, they've defined a diamond for me. This is how I use that operator. And sometimes you'll see even wackier things. you'll see things like let me draw. So they'll define. So this is, I don't know if you would even consider this an operator, but you'll see something like this. That by definition, if someone writes a symbol like this, and they put an A, B, C, let me write it this way, A, B, C, D, they'll say that this is the same thing as AD minus B, all of that over C. And once again, this is just a definition. They have this weird symbolic way of representing these variables and all this, but they're defining how do you evaluate this crazy expression. And so if someone were to say evaluate this diamond, let me evaluate the diamond. So evaluate the diamond, where in my little sections of the diamond I have a -1, a 5, a 3, and a 2. We would just use the definition of how to evaluate this diamond. And we would say, OK, every time we see an A, that is going to be -1. So we have a -1 times times D. Well, D is whatever's in the bottom right section of this diamond or this kite. So D is going to be 2. Let me write it this way. This is A, this is B, this is C, and this is D. So it's going to be -1 times 2 minus B. Well, B is 5, minus 5. All of that over C, which is 3. So this is going to be equal to -2 minus 5. So that is -7 over 3. And you could go crazy like this. And it might be a fun thing, actually, if you have some spare time. Define your own operators and see how creative you can get with those operators.